So, in the last class, okay, listen. So, in the last class, we were discussing about the data flow modeling, and wherein which we have studied certain examples which comprise of different expressions. So that is data flow modeling, and we have seen 10 different logical operators. So different operators which are involved in the data flow modeling. So using those operators, whenever we are going to model any circuit, digital circuit, that type of circuit modeling or digital circuit modeling will be considered as a data flow modeling. So now we will move on to the module 4, which is nothing but a behavioral level modeling. So this is the highest level of abstraction. So for any digital circuit, so there are 4 different levels of abstraction. One lowest level of abstraction is switch level, and next is gate level modeling, and third one is data flow modeling, and the final level of abstraction wherein which we are going to describe any hardware is behavior level modeling. So the highest level of abstraction is nothing but a behavior level modeling, which we are going to learn today. So now, as the process of VLSI has been introduced, so that means integrated circuits, so which keeps on increasing the complexity of the circuits, which has increased the complexity of the circuit. So whenever the increase of the circuit's complexity has increased, so the manually verification testing of the circuits will become difficult. So in order to overcome that, we are relying on the CAD tool, that is computerized design tool, which we are going to use to design as well as to simulate the behavior. So we have n number of CAD tools are available. So among that which you are learning in the lab, that is Xilinx tool, so which is also one of the CAD tool. So where you are going to model the hardware or digital circuit using the highest level, that is behavior level. So anyone who is not aware of the circuit can also able to program, or you can able to describe the hardware. So that type of modeling is called as the behavior level modeling. That means the programming model can have algorithm type of behavior, or it can have a flowchart type of behavior, can also be described in this type of modeling. So there is no specific rules that the designer should know interior or internal hardware content to be known. So without the knowledge of the hardware blocks, can also able to design a hardware. So that type of flexibility has been given in the currently nowadays the feature has been evolved in the CAD tool. So data flow requires knowledge about the operators, whereas gate level requires the knowledge about the gates which are available, whereas switch level requires the knowledge at the transistor level. Whereas in this behavior level, so there is no specific type based upon truth table and based upon the certain logic expression. So whatever the conditions, the program syntax can able to describe the hardware. So we have seen this in 2 to 4 decoder, where we have described the hardware of the 2 to 4 decoder using gate level, right? So in the lab we have described the hardware of 2 to 4 decoder using NAND gates only. The same type we have also described the full adder using the data flow modeling. And 8 to 3 priority encoder, we can see 8 to 1 mux can also be described in the behavior level. So that is behavior level means based upon certain conditions, we are going to check the conditions and we are going to provide the output. So that type of modeling is called as behavior level. So that is based upon the condition. So that is also called as a algorithm type behavior. So algorithm type of behavior, so wherein which after this condition, so next condition what is to be checked, like that based upon certain conditions to be evaluated. If it is true, then it is going to execute, otherwise the next condition is keeps on checking for all the possible operations. So that type of behavior we are going to study. So in this type of modeling can be used, or it can be used generally used in the higher level. So that means for any complex circuit, so wherein the design time is designing of a model block is very constrained is there you are going to use this behavior level modeling, because almost all the CAD tools which are available, so that is going to have a, what is that tool which is going to have nowadays? First time the typical design IC flow only we have seen, right? Based upon behavioral synthesis, it is going to turn into corresponding into gate level netlist. What is that process is called? Logic synthesis. So almost all the CAD tools is having logic synthesis tool. So if you describe the hardware in behavior level, that will automatically translate the higher level into corresponding gate level netlist. So that is one option which is having, so which greatly reduces the design time. So whenever complex circuit is there, so we are going for behavior level modeling, which greatly reduces the design time along with the time to market for the product. So that is being taken care by the logic synthesis tool. So now based upon that, so we will see. So what are the objectives which you are going to learn in this corresponding module? So in this, first we should understand when we are going to call it as a behavior level model. So already we have seen what are the 5 important component of a module. So in that, one of the important component is behavior level blocks. So behavior level block is also one of the important component, wherein which it comprises of 2 main basic procedures are involved. So one is always block, another one is initial block. So these are considered as the procedures because it is going to work infinite the loop. So within that loop, whatever the expression or the commands or the conditions or the any variable assignments has been given, it is going to be continuously monitored, and it is going to check the condition. If any one value gets changes, it will be changing in the corresponding output. So for that, we are going to have 2 important blocks. One is always block, another one is initial statement. So initial statement as well as always blocks will be having certain blocks of statements to be executed. So this always and initial block, if it is there, then blindly you can tell this is nothing but a behavior level modeling. And also Verilog is one of the language which is going to provide mixed level of abstraction can also be done. That means mixed level means, so you can mix data flow, behavior level as well as the gate level as well as the switch level. So all the 4 possibilities can also be mixed. So that is mixed level description is also being supported by the Verilog. Now we will be considering only on the behavior level statement, and what are the main important things that has to be there when we are going to describe the hardware in behavior level is always block as well as initial statement. So if these 2 statements are there, irrespective of the remaining things. So we can tell that the hardware programming language is being written in behavior level model. And then we are going to learn about blocking statement and non-blocking statement. So there are two important types of assignments which has been there in the behavior level model. One is blocking assignment, and the blocking assignment has been given by equal. So non-blocking statements are also there, which will be given with less than equal statement. So wherein which you can see some of the statements, you can see sum is equal to A XOR B XOR C. The same thing I can write in this non-blocking statement as A XOR B XOR C. So that is, we are going to see what is the basic difference between blocking and non-blocking. So blocking is the statement that blocks the next further statement to execute. Until this statement gets executed, it will not go to the next statement. So you can see in the simulation. Simulation only, initial statement will be there. After that, you will be assigning. Suppose if it is a Ray, Priyanka, ಏನ್ ರೇ ಏನಕ್ಕೆ ಹಿಂದೆ ತಿರುಗಿ ನೋಡ್ತಾ ಇರೋದಲ್ಲಿ ಏನ್ ಕೊಡ್ತಾ ಇರೋದು ಅಲ್ಲೇ ಕೂತ್ಕೊಳ್ರಿ if you are not having interest then why you are sitting here ನಿಮ್ಮೊಬ್ಬರಿಗೆಲ್ಲ ಎಲ್ಲರಿಗೂ ಅಷ್ಟೇನೆ ಒಬ್ರು ಯಾರು ಸಿಗ್ಬೇಕಲ್ಲ ನೀವೇ ಸಿಕ್ಕಾಕೊಂಡ್ರೆ you can see this statement, initial statements and all. So after certain time duration, you will be making reset is equal to 1 tick bit 0. So that is followed by #10. That means 0 to 10 nanosecond. After that, it is going to assign this statement. That means what? So after this reset statement being executed, even though if it is having multiple statements, S is equal to 1 tick bit 1, R is equal to 1 tick bit 0. So this is reset. Suppose if multiple statements are also there, so this equal symbol, so it is nothing but a blocking statement in the behavior level. So whenever this statement gets executed, then only this two statement will execute. Even though we are giving the same delay #10 followed by the series of the statements has been written, so all the statements will not, even though it is concurrently executed, but this blocking statement, if you are having any blocking assignment operator, so after this then only it is going to execute. So even though these are all statements is happening at 10 nanosecond, first the statement which is going to execute is reset, the next is S, and next is R. Whereas if I am going to use this, so it can have it, if it is having certain delay, it is there, it will not wait the next statement to execute. It will not delay, it will not make the Verilog simulator to delay for the next statement. So it will be after this statement, the next statement also will get executed, but this non-blocking will be assigned based upon the delay. Suppose if 10 nanosecond anmele this statement has to be executed, means it will not block the next statement series of the statements to execute. It will allow for the next statement, it will be executed only after 10 nanosecond. Like that, you will be seeing the difference between the blocking and non-blocking statement. After that, since we are going to work in this digital circuit hardware using based upon the certain timing controls are available, because you know that it is going to work based upon certain conditions. So based upon that condition, there are various type of controlling statements are available. First one is delay based timing control. So we have seen gate level as well as the data flow level. We have seen how to apply delay, because since we are describing the hardware circuit, so in any of the modeling, whether it is a gate level modeling, how to specify delay is important. The same way, how we are going to specify delay in the data flow modeling also we have seen. The same way, when we are describing the hardware in behavior level, there also how we are going to specify the delay. So understanding the delay based timing control. So based upon the delay, we are going to control the series of execution of the statement. So that is what the delay based timing control. So in this delay based timing control, again there are three different delays are associated. One is regular delay, one is intra assignment delay, and third one is zero delay. So you are familiar with what are the delays are available in gate level. What are the gate level delays there? Rise time, fall time, turn off time, and additional control, minimum type, typical type, maximum type. So the same thing, how you are going to specify delay in data flow modeling? What are the different delay? ಅಷ್ಟೇನಾ? ಅಯ್ಯೇ ಬರ್ದಿಲ್ವಾ ಇದು? ನೆಟ್ ಡಿಕ್ಲರೇಷನ್ ಡಿಲೇ ಓದಿದ್ರೋ ಇಲ್ಲೋ? ಅಯ್ಯೇ ಬರ್ದಿಲ್ವಾ? ಅದಕ್ಕೇನೆ ಬರ್ದಿದ್ದೀರಲ್ವಾ? ಸಮ್ ಆಫ್ ದಮ್ ಹ್ಯಾವ್ ರಿಟರ್ನ್ ರೈಟ್. ಆ ಡಿಲೇ ಕೇಳಿದ್ರೆ ಈ ಡಿಲೇ ಬರ್ದು ಹಾಕಿದ್ದೀರಾ ಬ್ಲೂ ಬುಕ್ ಅಲ್ಲಿ. That is why you have to see for which topic they have asked the program and what is the delay, because for every modeling we have to specify delay, because when we are modeling any digital hardware, so delay plays a major role. So how they are specified and what are the delays mentioned in the corresponding gate level, data flow, and this behavior level. So in this behavior level, so you are going to see how we are going to specify for regular delay and intra assignment. Assignment means what? So that is equal. So that is assignment operator. So intra assignment delay and zero delay. So here we are going to study three delays. So regular delay, intra assignment delay, and zero delay. And the next type of controlling the statements is based upon event. So we have seen SR flip flop. So what are the events which are required to model a flip flop? Flip flop model ಮಾಡಬೇಕು ಅಂದ್ರೆ, so when we want to write the program, already you have written the program, right? JK flip flop, SR flip flop, D flip flop ಎಲ್ಲ ಮರ್ದಿದಿರ್ತಾನೆ. HDL lab ಅಲ್ಲಿ you have executed, right? What are the different conditions or the controlling events which are going to take place? Clock is an event, right? Rising edge of the clock, so that is one event. Falling edge of the clock and falling edge of the reset. So whenever it happens, so those are all nothing but a event based timing control. That means event based, the programming logic is going, the program output is going to be different. So if the positive edge of the clock is there, and it will check for the inputs S and R, and at the same time it is going to monitor whether the reset event is going to take place. So if both the conditions are true, then what is going to happen? Reset is equal to 1 means irrespective of the inputs, the output will be Q will be 0, Q bar will be 1. If reset is equal to 0, then it will check the for every positive edge of the clock, that is rising event of the clock. So it will check the depending upon the S and R value, and it is going to provide the output. If both the condition S and R is equal to 1, so we are going to have different loop. So that is what the event based timing control. So same way we can have regular event control, and regular event control is nothing but clock. In sequential circuits we are going to represent clock as an event itself. So positive edge or negative edge of the clock. Manoj, Harsha ne tane, Gagandeep, Gagan, ಮೊಬೈಲ್ ಎತ್ಕೊಡು, ಕೈಯಲ್ಲಿ ಇಟ್ಕೊಂಡಿದೆಯಲ್ಲ ಅದೇ. So that will be event control. So regular event control, that is, suppose if I want to have one event by the designer itself, then we are going to name it as named event control. So which where you can give any variable can be assigned for name, and that can be added as an event. and event or control. So when both the two events are being matched, so you can use this event or control. The same way, when you are going to deal with the level sensitive signals, so that is latches and all, so which it is going to be considering for a level triggered signal, so 0 or 1. So like that, level sensitive signal which is going to model, so that is also going to control the sequential statements to execute. So that is also one way of controlling the mechanism in behavior level modeling. So delay is one, regular event type controlling, and third one is level sensitive timing control. So these are the three different event based which can be used to model for the behavior level. And next things which you are going to learn is in this module is conditional statement. So conditional statement means, so if and else if else is normal, if else if, and finally else. So that is the two types of conditional statements you are going to learn. And for loop and multi-way branching is another way of behavior level modeling. So whenever there is more than one sequential statements to execute, there we are going to use multi-way branching. So that is multi-way branching, how we are going to use, so using case statement. So based upon certain selection of the signal, you are going to provide the output. So that type of statement which is going to have is called as multi-way branching. So there are three alternatives that you are going to learn, because we are going to have 0, 1, x and z. So four different logic sets are available. So depending upon that, we are going to have three different multi-way branching statement. So case is going to work with respect to 0 and 1. Case x is going to work with respect to 0, 1 and x and z, and case z it is going to work with 0, 1 and z. So anyway, any four different logic sets, so you are going to have the multi-way branching statement. And looping, while loop, for loop, repeat and forever. So 100% they will ask what is the difference between while loop, for loop, repeat statement and forever statement. So some of the programs we are going to use repeat statement, some of the programs in the sequential circuits will be using forever statement. So some clock signal where we have written the program in the modeling for the flip-flops, in the test bench program we have written initial clock is equal to 1 tick bit 0, for always hash 5 clock will be equal to negation of clock, and we have used. So that means what? Until you run the simulation, the clock will be generating until the $finish statement will comprise, so it will come forward. So it is going to execute for that simulation. If you are using forever, if you are not using $finish, then it will be, normally the simulation will not end. It will be infinite loop. That means until you terminate, until you exit from the program, it will be keep on running. So in that statement, so forever, if you write a program for clock generation, it will be running till that time. So until you exit the simulation. So these are all the objectives which you are going to learn in this module. So now coming to the basic thing, by seeing it, so we are going to call it as a behavior level modeling. So that is structured procedures, so wherein which you will be having series of statements. So for loop, that is always an initial statement. So always and initial, if it is being used in any program, then it is behavior level model. So always means what? So always means any changes which is happening within the statement, so it is being monitored, and it will be infinite loop, that is not going to work with respect to until you terminate the simulation, that is by using $finish. So it will be keep on monitoring. So in that always statement, whatever the block of statements which comes under the always block, it will be keep on monitoring and you keep on executing until you run the simulation. So that is what the procedure. The same way initial block is also one of the behavior levels block. So that is behavior level procedure. So whenever we are going to use initial, it is going to start with the simulation at 0 nanosecond. So 0 second. So whatever the statement which comes next to initial statement, that means after initial block. So after initial block, if I am going to have reset is equal to 1 tick bit 0, that means it will be executing soon after the 0 nanosecond. So this is what the always block and initial block. So always block and initial block should never be nested. So never be nested means you should not have nesting of the always and initial block. But there can be one always block and multiple initial statement. So multiple initial statement can be there. Within that, any programs can be written. So based upon that, any number of initial statement if it is there, all the initial statement is going to start at 0 nanosecond itself, but depending upon the delay specifying inside the each of the initial block, the program execution is going to alter. But concurrently, all the initial blocks is going to start at 0 nanosecond. So any number of statements, suppose reset 1 tick bit 1 is there, so hash 5, here hash 10, s is equal to 1 tick bit 0, hash 20, r is equal to 1 tick bit 1. Suppose I am going to write this in the test bench, initial block within that one statement, another initial block with another statement. Like this, if I have multiple initial blocks, all the statement will start execute at 0 nanosecond, but first statement it is going to execute is reset. This block statement it will be executing, and second initial statement will be executed by this because 0 plus 10, so this value is going to execute, and it will be third initial statement after the initial block, it is going to execute this statement. So that is how it is going to work with the initial statement. So Verilog is a concurrent programming, unlike a C program wherein which it is going to execute in a sequential manner. So one after the other it is not going to execute, it is a concurrent programming. So depending upon the timing delay constraint or depending upon the event which is going to happen, certain things or certain statements is going to execute in concurrent manner, not in a sequential manner like a C program. And the always and initial block cannot be nested, as I mentioned. So nesting is nothing but keeping the loop within that inside. So that is nesting of the always and initial block is not required. So always block will be one, within that multiple initial block can be there, but nesting is within that initial statement. If I write another always statement is not allowed, because always will be, because whenever you initialize and if I write always statement, always it will be initializing with the new, with the previous old value itself. Hence it is nesting of the initial block and the always block is not allowed. So coming to the initial statement, so execution and all. So we can see one of the example here. So initial statement, module, register, and we have defined different variable names ABC, XY, ABM, and we are going to have initial statement. So here you can see what is the output. You have to write the output. So in this program, we are going to have three initial statement, initial blocks are there. So module followed by one initial block which is having only one statement. Second initial block is going to have two statements are there. In the third initial block, we are going to have another 2. In the fourth initial block, we are going to have one statement. So all the statement will get executed, will start executing at 0, but depending upon the delay, so you can see soon after the initial statement, the delay first encountered is nothing but #5, 0 plus 5, because within this initial statement we are going to have #5. So this is the first statement which is going to execute. So A will be equal to 1 tick bit 1. So next is 25 is there. So if you see in the next initial statement, #10 is there. So second statement which is going to execute is x is equal to 1 tick bit 0, because it is going to have only 10 nanosecond. So 0 plus 10, 10 nanosecond it is going to have. So first is m value will be have in the, sorry, m is also there, huh? 0 nanosecond. Okay, so here one statement is there. So 0 nanosecond, we are not having any delay. So here it will be, since it is not having any delay, so this statement will be executed first, second, and third is x value. Fourth is, this is also 25 is there. 25 plus 5, 30 nanosecond. Whereas here 25 y is there. So after x, y statement will get executed. After y, at 30 nanosecond, B value will get executed. So you have to model. So you write the program, I will tell. So the output hang barutenta, they will ask. So this program they will give, and they will ask what is the sequence of the output you will be getting. In order to make sure that it is going to start and it is going to be working with respect to concurrent programming, so they have given with the multiple initial block. So multiple initial block for series of statements they will give, and they will ask you to find or write the corresponding output. So this is how the output you will be getting. So initial statement will be starting at 0 simulation time, followed by, if multiple initial blocks are there, it is going to work with respect to corresponding delay. So with respect to delay specified, so you will be getting the output. So now another thing is that, so combined variable declaration and initialization. So when I am going to write the program in the HDL lab, output register y is equal to 3 tick bit 111. So like that I was specifying, when I was defining the ports, at the same time I was defining register in order to avoid 2 times of declaring. So I can write, while defining the port, I can define whether it is of what type of data type, whether you are going to use as a register data type or real data type, integer data type, anything can be combined variable declaration along with initialization also can be done. That means instead of reset value is equal to 1 tick bit 0 after the initial statement, instead of doing that, whenever when I am defining the register as a reset, there only register reset is equal to 1 tick bit 0. So if I define, I am going to define the data type, at the same time initialization of that value also being done at the same time. So that is combined variable declaration and initialization. So here there is an example, register I am going to define as clock, and in the clock defining, so register clock is equal to, sorry, initial clock is equal to 0 on the 2 statement. Instead of doing these 2 statement, I can initialize the value of the clock when I am initializing the data type itself. So register clock is equal to 0 or 1 tick bit 0. So anything you can do. So this will avoid 2 time or 2 type of statement can be reduced to 1. So that is combined variable declaration and initialization. So the same way combined port declaration and initialization. So port means what? Input port, output port, input port. So when I am defining the port, I can define whether the data type is of register or real. So here you can see output register C0 is equal to 0. So the value of C0 is initialized to 0 when I am defining the port itself. So this type of declaration is called as combined port initialization and declaration. So with this I'll just conclude today's